Yes, I'm Andrew Craig, President of Great Southern Flameless, and we're going to be talking about our very advanced technology in the fire heating industry, and it's a huge, huge advancement in the way, and really it's by far leaps and bounds beyond the traditional or even technologies today. It's one of the few approved by the Southern California initiatives for NOx reduction on the SQAMD, and it's also recognized by the DOE for Title 17 and emerging technologies. And really, it's just, not only is it an advancement in technology, but it's such a huge benefit and advantage to have a GSF heater in service, because not only because of the ability to get NOx emissions, but it's super reliable. You know, traditional heaters today, and even the burners with it, they really rely on each other to work, and the burners have to be sized in a way that fits the heater application and how they're arranged in the space between the burner and the tubes and the burner and the burners. Well, ours is a system. It's purposely built for the application. So it has a much broader range of controllability and is able to just really smooth out the operations experience. I mean, really, today's technologies, or I should say prior arts, are really dependent on how the currents are in the firebox. You know, and also they can become victim to them. They can, you know, if under turn down race, burners can be challenged, or later technologies can be, and also even higher ends. The beauty about ours is it can handle those ranges, and not only that, but also can handle advanced fuels. I mean, there's a whole lot of discussion about hydrogen fuel and oxygen fuel. Well, our heater can accommodate those without having to change the heater design. And that's huge, especially when we're talking about these new refineries that we're considering, and one actually that our technology is considered for this new refinery in Oklahoma, is it allows the ability to design and operate under these advanced fuels, but then can flex to traditional refinery fuel gases, where other traditional heaters can't do that. I mean, if we went to advanced fuels, then the heater's not going to perform as well. The radiant's going to have to perform much more than it would normally, and that has consequences. But our design and our technology doesn't have to do that, and it's really driven by how we do it in diffusion combustion versus you know, super staging or turbulent combustion that traditional burners are required to do. Again, ours is a system, so it doesn't have to have that. So again, it makes it more reliable and cost efficient for the client. We are an advanced technology company. We're driven by technology, and one of our most significant advancement is our cool combustion fired heater. And it is a huge advancement compared to the traditional fired heaters we know today, or the prior arts. Because of the advancement, the flexibility it gives to clients, and it's been recognized by California and driven by the SQAMD for their initiatives for NOx reduction. And then also the DOE has recognized our technology, emerging technology, to satisfy the Title 17 requirements. So it's really recognized not only in the industry, but then, you know, also by the government partners to really drive this advancement in how we operate and build and design advanced heaters and advanced refineries. I mean, look at this one that's coming up that we're vetting for the new refinery in Oklahoma. Because of our technology, it really gives them an advantage on how they can achieve the strict requirements of permitting and things like that. It's what our heater can do for them. Really, it sounds very advanced. It is advanced, but it doesn't mean it's going to be harder to operate. The operators can do the same thing they do with the traditional heater as they do ours, and it's very reliable. We got this one that's been in operation for quite some time now, and it hasn't required any additional maintenance. Quite frankly, it's quite less maintenance than any of the other heaters. I mean, ours has been running now consistently without having to decoke, and it's in a black oil service, and that's huge. And not to mention, there's no tip fouling because of large port sizes. It gives such more flexibility to the clients, because, you know, it's a system. It's built together. The burners are built with the heater. It's a component that is purposely built for them. And by doing that, the burners and the heater work together. You know, today with the current technologies or traditional fired heaters, the burners are very sensitive. How are we going to get the space between the burner and the tubes and the burner to burner? And we have to really flex around what we think the flue gas flow patterns are going to be inside the furnace. We don't have to worry about that in our technology with our design, because of the way we do diffusion combustion. So where traditional arts may have a suite or a range of operations, but they can come victim to turndowns, and there we have challenges with emissions on the CO side, and then we got the high ends where a lot of times refineries or clients will design a furnace, but then in the end it's going to be running harder, and so when they get to that higher rate, then there'll be challenges with that. Well, when you have a system or a purposely built unit, that's taken care of. And ours, because of the diffusion combustion, is allowed to do that. We're not designing our furnace with super staging or really trying to excite molecules by colliding them. We're diffusing the reactants together to get to the product we want, which is the same end product as you would with anything else. It just really lines in with the current needs, but with much more flexibility. So with the diffusion combustion, it allows us to go in the highs and the lows without really seeing a challenge. And today there's a whole lot of hype about hydrogen fuel and oxy-fuels and things like that. Well, on a traditional furnace, if you switch over to those advanced fuels, it's not going to run as well. The convection section is going to be challenged. So now the radiant's so you get fire harder, and just things you got to accommodate. But with ours, the way how efficient the radiant section is and the way it operates is we don't have those challenges. It can go from advanced fuels and swap over to the traditional fuels and back and forth and within the same unit. And that is something that the current art and current technology just can't do. And that's why it's so interesting to clients, and that's why we have so much interest in driving this technology forward, because not only does it meet the new criterias or the ones they're pushing, but also helps with the green energy initiatives with using hydrogen and oxygen, but then also it's very reliable.
This video is going to show you the switch from conventional combustion to flameless combustion or cool combustion inside the heater operating at coffee film. In the video you're looking at, you are seeing conventional combustion and the switch over to flameless combustion. The first thing you will notice is the cool combustion burner will go from conventional to flameless, and we still have flame on the other wall coming down the wall, and then it also goes flameless. Now you see the pilot, and you see that as you watch this, you will see the firebox clears up as it stabilizes in the flameless combustion mode. We are now going to show CFD modeling of the Coffeyville heater, and on the left side is conventional combustion, and on the right hand side is the same heater in flameless combustion. And you will notice how hot it is in areas where the fuel tips are in front of the air in conventional combustion, and then on the right hand side how cool the combustion is when we've moved the fuel away from the air nozzles and we're in flameless combustion. You might ask, why do we want this cooler combustion? And the reason is we want to be not making emissions, especially initially it was NOx, but now we can really cut down on other emissions too with this purpose-built design. So that's why we want to do it, and that's why it's been so effective to advance the technology of direct-fired heaters.